Hey, this is Shane, and welcome to video 3 on how to create a 3D level using dungeon level builder in Unity. Now, I'm gonna have to call dungeon level builder DLB from now on, because dungeon level builder is kind of long to say, and it gets me a little tongue twisted as well. So we're gonna refer to dungeon level builder from now on as DLB. So welcome to the video on how to build a 3D level in Unity using DLB. So in the last video we had the flow created, and I showed you the power of the visual theming system in terms of probabilities and how quick it is to get something like this up and running, where we have our room flows defined, our hallway flows defined, and a little bit of probability giving us a light variation in terms of what tiles we've placed. So today we're going to create the walls for these rooms, and we're also going to deal with the lighting, because it's one of my pet peeves, is when something I'm doing looks relatively flat. So let's start with the lighting over here. Now we have a directional light defined in the scene over here, which is something that I'm not a big fan of. Let us take that off. Let's make sure that we have just a flat color for the background. So let's make sure that the skybox is taken off as well, and that we're looking at just a flat gray as the background color. Now, in order to do that in the scene view, let's make sure that we don't have a skybox. So that's much better. Now, now you can get really nice results with your skybox, and Unity is great at coming up with these really photorealistic results. But for the case of our tutorial and our time limits, I'm going to make sure that I'm not using any of the real-time lighting options. No, I'm not using any of Enlightened's options over here, and I'm just using point lights to provide my lighting. So let's open up our theme file again, and we want to have the lights spawn just above the floor tiles in certain areas. And we're not going to have an actual light holder, we're just going to have a point light prefab spawn a certain distance above the ground. So the way we're going to do that is we have we're going to have a game object node over here, which will take care of our lighting, and our lights are going to be handled by this node over here. So to do that, we'll create a placeholder empty node, and we'll create a node that holds a point light. So let's go. I have a prefab in here for the point light I want, so that's the point light I want. I'm going to hook it up, and I'll hook it up to this over here. Yeah. Now, if I left it like this, and I actually went and generated the level, you're going to see that there'll be gaps where these lights spawn. So every place the light spawns, we have a gap, because the level generation algorithm over here is deciding, the level visual generation algorithm over here is deciding to spawn a light instead of these floor tiles in those particular areas. And what we actually want is for the floor tiles to spawn and to choose between each of them. So basically it's either this floor tile or this floor tile, but if a light spawns, it spawns without interrupting these tiles from spawning. So the way we do that is to say, I want this tile to always be placed, and when I say that, when I click on that option, we lose our probability over here for this node to be placed. This node will always be placed above a floor tile, and in this case above a main room floor and a standard room floor tile. We can also connect it to our hallway floor tile, but will not actually interrupt the other child tiles that are placed over here. So with that being said, if we spawn the level right now, we're going to have lights all over the place, meaning we're going to have a light for every floor tile that we have, and that's not exactly what we want. We want a light to spawn at a particular probability. So to do that, let's define not a custom tile node. Let's remove that. Let's define an empty game object node over here that will eat up the probability for the tile, for the light being spawned. So let's say 10 times that we have this tile spawning, that it spawns an empty node, basically nothing. So for every 10 times this thing spawns, it'll spawn nothing. But on the 11th time, it's going to spawn a point light, and we want this point light to be 5 spaces up on the y-axis. So we'll have 5 on the y. Now what we're going to have is, if we go back to my level manager script, is relatively nice lighting conditions. Now it doesn't look all that great from this view, and that's understandable because we are talking about my point lights are turned to not important lights, which turn them into they're not exactly pixel lights. But when you're actually playing the level, they look relatively decent and they give you great performance. So we have our level lit up like this. Let's one more thing. So in order to create these nodes, I'm right-clicking on my level theme editor window to create to get this menu option over here. And to connect tiles, I left-click on the connector on top, and then left-click on the connector from the parent, and it will connect it. So for instance, if I wanted to create this, connect this to this, I left-click and left-click. Now if I wanted to disconnect, I right-click and it will disconnect everything that's connected to it. So that's how you do that. That was something that I had overlooked in the previous video that you now know how to do. So let's get back to building the walls. And our level basically has 2 types of walls. We have walls that surround our rooms and walls that surround our hallways. So let's create the walls that surround the rooms. And we have tags that spawn when we create a new level theme file that contains options for just that thing. We have room wall tags for main room walls and standard room walls. In this case, we're going to have both of them have the same type of wall. So let's bring the 2 of them together and create a game object node that's going to hold our wall. And the prefab for the wall is prop wall D, I think. Yeah, that's the wall we want to spawn. And let's connect it up and have a look at what we get. So the moment I build this, you're going to see that these walls are spawned correctly. It's just that they've spawned at the wrong rotation, and the height's fine. Let's look at it from the side. The height's fine, it's just that the rotation's off. So in order to change that, let's go in there, and I've built this before, so I know what the rotation required is negative 90 degrees on the y-axis, and that will fix the rotation we have over here to make sure that the walls okay, and that, yeah, don't know, did I change something else to negative 90? Yeah. Negative 90. Apologies, my keyboard is malfunctioning on me, but we should be good now. Yeah. So we fixed the rotation of the walls, and you have walls around your rooms right now. And if we wanted to have variations in walls, you could. exactly the same way that you would have variations in the ground tiles, you could have variations in the walls. But for the sake of this tutorial that I'm doing, this is good enough for now. So our wall tiles have been spawned, and we have now, to explain the rotation offset over here a little bit, is it's basically your prefab is going to be spawned, and after the prefab is spawned, inheriting the tile position from the parent node over here, it will then apply whatever values are there in this offset. Now, this offset can have fixed values, or it can have randomized values. Now, if you wanted a randomized value for the rotation, for instance, you could have a value between 0 and -90. Now, -90. Now, this is not what we want, but I'll show you the results that we get over here. We'd have some interestingly rotated walls over here, all around the y-axis, and we could do this around any axis we wanted to. But that gives you an idea of what those offsets actually do. So let's fix it back. Let's make sure that the randomized offset is taken out, and then we just have an offset of -90 on the y. So we have the walls around our rooms are built. Let's build the walls around our hallway, our corridors. So it's exactly the same process. We have the option for hallway walls over here, and I add a game object node. I connect it up by left clicking on the connector nodes, and I go looking for prop, and it's one of these walls over here. Let's just open it up a little bit. It's not that, it's this. Which one is it? Wall panel B. Okay. So it's prop wall panel B, which is prop wall panel B dot. Okay. We have panel A. Let's just prop wall panel B prefab right there. Yeah. And again, to preempt the rotation problem, let's give it a -90 rotation, and we should have the walls around our corridors. That looks nice. The lighting looks pretty nice as well, which makes me happy, personally. But yeah, more to the point, the walls are created. Now, the walls on the sample have security cameras attached to them at certain spots, and let's do that, and I'll show you how easy that is to do. So we want the security cameras to be attached with a probability of 1:5. So in order to do that, let's add an empty game object node over here to eat the probability, the 5 probability over there, and then let's add code for let's add a node for my security camera. Let's find the security camera, which is prop CCTV, and make sure you pick the prefabs over here, and this should work. It's just that our rotation would be off, and our CC our cameras will be spawned at the bottom of our wall tiles like that, and that's not exactly what we want. We want them to be rotated and facing inwards. So in order to do that, we apply an offset to these cameras, and the offset that is needed is 2.2 on the y-axis, and a 90-degree rotation. Now another important option over here is that this offset would work only if the tile actually inherited the parent's offset. And the parent has an offset, as we discussed earlier, of 90 degrees, the rotation of 90 degrees. So in order for that particular offset to work, you need to inherit the parent offset. And it's easy to think about, but basically what we're talking about is that the tile position that this game object node is going to receive will have the offset that the parent has, in this case negative 90 on the y, applied to it. So from the point of view of this game object, this prefab, the tile position it receives is going to have that 90 degree rotation applied to it already. So it's not going to know about it, but it's going to think that, okay, that's the place I'm supposed to spawn at, and that's the rotation I'm supposed to spawn at. In the case of the security camera, we want to inherit the parent offset and then apply our particular offset to it. And some of these concepts you're going to have to play with to truly understand, but after you do, okay, and we are looking at a negative 90, not so much a 90. Let's go back to our scene file and build it. Yep. So now we got our security cameras connected, and the security cameras have a script attached to them. So let's have a look at what that looks like. Make sure we're not, my camera is not set up, but you can have a look at it in the scene view. So let's go back to the scene view, and you should be able to see the security cameras turn a little bit, but that's just for aesthetic purposes. So you've learned how to attach walls, and you've learned how to attach game objects to other game objects. In the next video, we're going to learn how to deal with our obstacles, and in the process of doing that, we're going to get into the pattern matching system that DLD, Dungeon Level Designer, a dungeon level builder, has. So, to the next video.